I can still follow instructions. Okay, as I said, the bridge office asked me to put this together. So that presentation was January 21st. And so here we go, back to the time when I started working with VDOT. And this is about our rigid bridge overlay activities. It's not just about latex, but the majority of it is about latex. So from about 1970 to 80, VDOT placed LMC overlays on all new bridges to achieve a longer service life. And you wouldn't believe how many VDOT folks did not even know this because they weren't around then. But anyway, at that time, decks were sandblasted and overlays were about 1.5 inches thick. And actually, the first overlay that we did was a latex mortar placed on I-85 over the Roanoke River in 1969. And that placement was because the cover was so shy on the new bridge over the Roanoke River. So they put the mortar system down to increase the cover and to protect the rebar. And at that time in the 60s, Dow Chemical was actually recommending a mortar, but they soon started recommending concrete overlay rather than a mortar. So in 1974, the research division got involved in the overlay program to see if we can improve things. And so we did we put overlays on 2 bridges on Route 340 near Berryville. And again, these were new bridges, but VDOT was interested in trying alternatives to latex. So these were 3-span bridges. So we had 2 LMC overlays, 2 steel fiber reinforced concrete overlays, and an A4 post and rail mix, which is just a bridge deck mix, but it's got the 1/2-inch maximum size aggregate. And these decks perform quite well, and they're still out there. They've got a lot of patches, but they're still there. And then in 1977, again, to see if there were alternatives to latex that might be better, we did the first low sump overlay. And this was a new bridge on US 301 at Port Royal, Virginia. The deck was sandblasted. And the overlay failed almost immediately because of poor bond, and the decision was made to replace it with latex modified concrete. And as far as I know, that latex overlay is still there, performing okay. And I remember seeing the mix, and the slump was so low and the mix was so dry, and it just never bonded. It never had a chance. And as a result of this failure on the first attempt to use low sump overlays, VDOT never tried low sump overlays again. So this experience showed me that it's very important to get the first one done correctly. So in 1980, VDOT began using epoxy coated rebar in new bridge decks, and many DOTs started using epoxy coated rebar in new bridges. And so the additional cost of epoxy coated rebar was less than an LMC overlay on black bar. So use of LMC overlays on new decks was discontinued. But fortunately, at that same time, VDOT began placing LMC on its older bridges that had been constructed years back with black bar. And the intent was to extend their life, increase the cover, and have a lower permeability protective system on these older decks. And decks were typically milled to remove about 3/4 inches of the top surface, and they were sandblasted. And so this was the sort of thing that was going on at that time, beginning about 1980. And then with increases in volumes of traffic on many interstate bridges and heavily traveled primaries and all, we began to experiment with polymer overlays and began to use polymer overlays on these type bridges. One, because of the lower initial cost, but mostly because of the short cure time. So some of the bridges that would have gotten latex were now getting polymer overlays. In '85, VDOT constructed its first higher strength latex modified overlay with type 3 cement and a 24-hour cure time before you put traffic on it. And again, this was an attempt to have a latex overlay that you could drive on in a short time so that latex could be used rather than a polymer overlay. This overlay was on US 340 in the Stanton District and performed well until the bridge was actually replaced because it was obsolete. And then in '87, VDOT constructed its first experimental silica fume overlay. And we did spans with 7% silica fume and 10% silica fume. And this overlay was on US 50 near Winchester. And if you probably can recall, if you were working back then, that every time you went to meetings, the overlays that were talked about were silica fume overlays. That was the new overlay system, and everybody was talking about silica fume, and there was rarely any presentations on latex. So a lot of silica fume overlays were constructed. And so in 1990, VDOT approved 7% silica fume overlays as an alternative to latex modified concrete because of the potential low cost compared to latex, and decks were milled and shot blasted. And we actually have this policy in place now. And on some projects where there's a ready-mix plant near the bridge, and the bridge engineers have had good experience with silica fume, silica fume will be used assuming it's bid lower than latex. And again, everything's based on low bid. But the vast majority of the overlays today, silica fume is not an option and latex is used. About 1990, because of the problems with plastic shrinkage cracking in the overlays, the specification for gravity field crack sealers that could be used to fill these shrinkage cracks and overlays was implemented. And we still use that to this day. In 1994, FHWA funded a thin bonded overlay program. Overlays were becoming very popular at that time, and FHWA felt like it was good to demonstrate all the different types of overlays. So DOTs could get money to pay for delta cost for different kinds of overlays. So in '94, VDOT placed LMC and silica fume overlays on 6 bridges on I-95 near Emporia, Virginia. This is down near the North Carolina line. And 2 of these 6 bridges, traffic was placed on one LMC high early and one 7% silica fume overlays after just 24 hours of curing. These overlays are all still there. So you're talking about 27 years. The interesting thing on that project was tensile bond strengths were only about 100 PSI, with failures in the top surface of the deck caused by milling fractures. And, that's when the older milling machines with the older milling heads were being used. And they tended to do damage to the deck and lower the bond strength. But the good news is from this, we realized that you don't have to have that high bond strength for overlays to perform well. So these overlays are still there with bond strengths that were initially only about 100 PSI. In 1996, again, with FHWA thin bonded overlay program funding, we thought we would try every overlay system that could be that was available to use at that time. And so we had 2 28-span bridges on US 60 Lynnhaven Inlet. And these spans, most of the spans were 50-foot spans on pre-stressed beams. So this gave us the opportunity. The deck was really in good condition. The deck bridge belonged to the city of Virginia Beach, and they wanted the funding. And so they let us put the 16 different mixtures on these bridges. And we used latex on the center spans, which were longer than 50 feet, and they were on steel beams. And we used 7% silica fume, steel, polypropylene, olefin fibers, 40% slag, silica fume fly ash, silica fume slag, shrinkage reducing admixtures, corrosion inhibiting admixtures, and we actually did a 3/4 inch thick silica fume overlay with 13% silica fume. So if we were aware of other mixtures at that time, we would have tried them, but these were the mixtures that we came up with that were recommended for use or had at least been tried somewhere. And the interesting thing about this project was we just shot blasted the deck prior to placing these overlays. You know, the contractors had invested in shot blasters at that time for use in putting down polymer overlays. And the concrete deck, even though it was 1940 and 1950 concrete, so we're talking about 45 to 55-year-old concrete, the deck concrete surface was in really good condition. There were no patches and no cracks, and and we just thought shot blasting would be good enough. So that's all we did was a good shot blast. We did no milling, no hydroblasting. These overlays performed very well until the bridge was replaced in 2015. It's really unfortunate the bridge was replaced because we'd like to have kept up with these overlays for a longer period of time. And then our real breakthrough was in 1997. And we had used a very early strength LMC for patching bridges on the interstate at night since about 1990. And the patching work was going really well, and the patches were getting larger, and the work was going well. And the contractors actually came to me and said, we'd like to actually do a whole overlay using this system. So we used the very early strength LMC, which you can drive on in 3 hours on US 33 Old Mackinac River at West Point. And the work was all done. They do 3-lane spans at night, each night. It was a very long bridge. And then that was successful. So in 98, we did the second overlay, and this was up in Northern Virginia near DC, where there's a lot of traffic. And this was placed at night. It was a 3-lane bridge, and was placed 4 nights in 1998, and it was over Interstate 495. And it performed well until the bridge was replaced recently. Then in the late 90s, we began to use hydro demolition for concrete removal and surface prep. And the first use of that was in the Stanton and Salem districts. And I say or there, I don't know which one did the first one, but that's when the hydro began to be used. And then other good news was about 2000, micro milling heads, which don't damage the deck surface, begin to be used for deck surface concrete removal. And the micro milling heads are very little pointed milling heads, and they almost are like, give you the effect of a grinding machine. But these milling heads would allow you to have really high bond strengths because you were not damaging the concrete. And they really came into use because the contractors were required to use them for asphalt resurfacing work. And so the concrete industry was able to benefit from the use of these milling heads. And then in 04, again, to address cracking issues, we constructed the first LMC overlay with tight case cement. And this bridge was on US 221 near Floyd, Virginia. And it was a very successful installation, and the district liked it so much they did a whole lot of overlays with LMC with tight case cement. And then in 2014, we constructed our first overlays with lightweight concrete. This is like a bridge deck mix with lightweight aggregate, but half-inch maximum size aggregate. And we also did other overlays with 7% silica fume, LMC, very early strength LMC, and strength reducing admixtures. And the overlays were placed on 2 bridges on I-64 near Covington, which is over near the West Virginia line. And these overlays are all performing well. So about 2000 till today there has been increase in use of very early strength LMC overlays. And the reason is on most of our interstates, traffic volumes are just so high, the traffic division will not let us close lanes except at night. And if we're fortunate, they'll let us close lanes over a weekend. And so about the only hydraulic cement concrete mix you can use is a very early strength LMC. And then in 2017, this is just 3 to 4 years ago, two reports were done. One was the performance of bridge deck overlays, phase 1, and then 2019, phase 2. And the phase 2 report, they looked at all of the data on bridges in Virginia and identified 177 bridges to evaluate the performance. And it was all done in the office. There was no coring of these overlays or anything, but the condition of the overlays was based on the safety inspection reports that's done every 2 years. And anyway, the study came up with a conclusion that thin epoxy overlays last 18 to 22 years on the average with a 95% confidence level. And hydraulic cement concrete overlays, which were mostly latex and very early strength latex. There were very few silica fume overlays in the evaluation, but they came up with a 21 to 32 year service life with a 95% confidence level. So this was very important, and it was kind of something that we knew. And one of the issues with the rigid overlays was that many of them were still in good condition after 32 years. So you're trying to compute an average based on a life that you have to kind of predict. About 2010 to the present, there's been increasing use of hydro demolition type A and type B prior to placing overlays, because we get the absolute best bond strength and best curing and all when the deck concrete is prepared with hydro and saturated with the water, which helps you get good cure of the overlay and excellent bond. And the early bridges were on the interstate, I-64 eastbound, east of Richmond. There were 12 bridges in the Lynchburg district, and then I-64 near Covington. And then in 2016, we revised the road and bridge specification. And so it now has the requirements for hydro demolition spelled out in there in the VDOT road and bridge spec. And then in 2020, there was the NCHRP report on hydro demolition called the SCAN report. So kind of in summary, we've been using mostly LMC overlays as far as rigid overlays since 1970. Beginning in 87, we started using silica fume overlays, and they're still allowed and they're still being used on occasion, but the majority of the overlays we do are latex. And then the very early strength LMC overlays we started using in 1997. And as you can tell from the work we've done over the years as part of the various research projects, that many material combinations can be successfully used for overlays. And it's kind of my opinion, workmanship is the most important factor for long-lasting overlays. And if you get a contractor that can use the material and place it satisfactorily and make sure he gets good curing and all, you're going to get a really good result. And we have latex overlays out there that I know that are 40 years old. So, questions?
I have a question, Mike.
Okay.
Do you see any difference in the longevity of the overlays if it's placed on a milled surface versus a hydro surface?
I don't know that we can conclude that at this time. because we don't have the years of experience with the hydro. But I do know that I've taken cores from decks that were shot blasted, milled, uh, and where hydro was used. And you clearly get the absolute best adhesion and bond and interlock with the hydro. And so that information would suggest that you can probably get the maximum life you're going to get uh, using hydro. And sometimes the life's just controlled by the quality of the old bridge deck, and
Yeah.
uh,
Yeah.
so there's only so much life you can get, when you're overlaying real old concrete that's not in good condition.
Oh, we're doing second and in some cases third generation concrete overlays now since the 1970s, and it's really amazing how them concrete overlays protect bridge decks when we peel them off and hydro them, and it's pretty amazing, I'll tell you.
Hey, Michael, I have
Thanks,
a
Mike.
question.
That was a great presentation.
I have a question, Michael. Um, the latex modified concrete has a specific FHWA standard, the FHWA RD78-35. And I know that when you read through that standard, you know that Dow had a hand in writing that because they were the ones that developed and designed this technology. Are there FHWA standards written for these other technologies? And if not, how do those technologies get approved for use?
I don't know if I can answer that question. It's an excellent question. Back in the 70s, it was kind of the way business was done. FHWA was, heavily involved in approving systems. Back then, latex was approved for use, membranes were approved for use, and but you had to meet the FHWA requirements. And I don't know that sort of policy has continued over the years. You would have to talk with someone from FHWA, but I'm not aware of any specific the FHWA requirements. I know there's requirements, ASTM requirements for silica fume. So that's allowed, controls what silica fume is used, but it doesn't, that's just that material alone. Um, so I know I'm not answering your question.
Yeah, thank you. I think you've answered it kind of like I would have answered it, because I don't think there are standards for these other technologies, and I was just curious how they made it into this, because the LMC was a technology that was engineered specifically for overlays, and some of these other technologies were not. They were designed for other systems and just happened to be used.
You're exactly right. I tell people latex modified concrete was one system that was designed and developed to be used for bridge overlay and for no other use. That was the intent of that product. And the originators of it did a great job, in my opinion, because the same mix is still used today. The main change is that we're using the rapid set cement, but again, the mix is still the same. So that's been around. That mix has been around since about 1970.
Thank you.
You find you need specialty contractors to provide and install that kind of overlay, the latex overlay?
Yes, I would say that that's the key to success, is to have a contractor that has a mobile mixer and has the ability to use latex modified concrete. And in the early days, the contractors had to be approved by Dow to actually use the product and to do overlays. And of course, there was some concerns that this was not legal or whatever. I don't know what happened, but that went away. But clearly, you have to know what you're doing to place latex overlay successfully. And when you've got a contractor that knows how to do it, you're going to get a good overlay. It's almost impossible not to get a good overlay.
When you're doing an overlay because of lack of cover over the rebar, how thick can you go with it?
Well, that's a good question about the thickness of latex overlays. The minimum has always been 1.25 inches, and because of variability, you tend to get 1.5 inches on average with a minimum thickness overlay. And it's designed to be placed 1.5 to 2 inches because you're using a 1/2 inch maximum size coarse aggregate. But over the years, we've used thicker and thicker overlays successfully. And I know in general, when you get most specifications for overlays, say pavement overlays, whatever, they talk about a 4-inch maximum. I think, once you get to these greater thicknesses, you may want to consider using a number 57 larger coarse aggregate. But I'm going to tell you, one of my reports I did in the 80s was called Overview of Latex Modified Concrete. That was a latex overlay that we evaluated that was about 8 inches thick at that time. It was on I-81 near Salem. And then several years ago, we did what's called a connection closure pour type installation on a bridge. It was 120 feet long on I-81. So we're connecting a widened part of the bridge with the existing bridge. And so the placement was about 8 to 10 feet wide, 9 inches thick, and 120 feet long. And they backed out 2 mobile mixers, one headed north, one headed south to the center of the bridge. And they placed rapid set latex modified concrete, 9 inches thick, 120 feet long, 8.5 to 9 feet wide, successfully, with interstate traffic driving on one side of the bridge. So we've got examples of real thick placements that were successful. That's all I can tell you.
A lot of times the overlays poured the same time as variable depth areas are poured. They pour it monolithically, so you have your 1.5 inch uniform overlay. But some of those variable depth areas, Mike, I've seen, 5 or 6 inches deep. They'll go all the way almost to the bottom rebar if the concrete's bad after the hydro demolition's done. So, and that's most specs allow that monolithic pour.
No, we've been doing that type application since the 80s. Originally, the VDOT required the deck to be patched first. Mm-hmm. And then in order to save time and money, they started trying just doing the patching, both full depth and partial depth patching at the same time they place the overlay. And that's been the standard practice in Virginia since the 80s. So, yeah, that's the longer lasting experience with thicker installations.
Excellent. Anybody else have any more questions for Mike? Now's the time to ask. Or you can send it to that email, of course. Mike.
What would be the advantage of latex over just a regular Class D concrete, which is more readily available?
What I tell people is you tend to get the lower permeability. You had the potential to get better adhesion, better bond strength, assuming you've got a properly prepared surface. That's I guess that's the main reason. If you can do this D mix you're talking about there, I believe you must be from Delaware, successfully with no shrinkage cracks and you got pozzolan, slag, flash, or what, silica fume, whatever in the mix, and you can do it and not get cracking, then that's fine, you know. And again, to this day, we're still doing 7% silica fume overlays in situations where you've got a contractor that knows how to do overlays, you got a ready mix plant nearby, and they do a good installation, and we get a silica fume overlay with no cracks in it. So there are alternatives to latex modified concrete. So I'm not going to, you know, this presentation should indicate that VDOT's tried different options, and we've shown that many different options can work, again, with good surface prep, good placement, and good curing procedure.
I'd like to add, we did all the hydro prep and removal of existing latex overlays on I-95 there in Wilmington, and those old overlays, they really protected that bridge well. That's like kind of some nice proof, some nice actual long-term. I think those have achieved 30 years of service life, maybe there in Wilmington, and now you're replacing them with the Class D and the second generation. And 30 years from now, you'll be able to tell.
One thing I forgot to mention, and I just thought of, is the permeability of latex modified concrete continues to get better with age. And we've got published reports showing that. Permeability of silica fume overlays does not get better with age. It kind of, it's good to start with, you know, 1,000 coulombs, whatever. But it stays there. But the permeability of latex modified concrete drops lower and lower over time. So it just gets better with age.
I've seen Mike's report on that. Very interesting.
You must be checking the permeability with some pretty good wine then, huh?
We purposely went out and cored some older bridges so we could plot the permeability over time, and we actually had some bridges where they did not achieve the permeability when they were originally constructed, and there was some concern about taking them out. And you know, sometimes latex does not give you the low permeability initially. Silica fume, you get it almost instantly. It's no problem meeting the spec for permeability, but sometimes you don't get it with latex initially. So I published a TRB paper that shows that over time you will meet the spec with latex modified concrete. You just, sometimes you have to wait, but the good news is it continues to get better and better.
Michael, this is Darren from IH Engineers. Since you mentioned about the permeability, when we use the latex, do we need to use waterproofing membrane anymore?
No. You're going to get, with latex modified concrete, you're going to get coulomb values that are 1,000 or lower. So you're in the very low range. And we checked the permeability of rapid set latex modified concrete after a number of years, and it was down to almost zero, which you can only do that with some polymer concretes.
But based on, the traditional construction, we place the waterproofing membrane underneath the concrete deck. So they are kind of protected from the concrete deck. But if we use the latex, it's serving as a membrane and also the concrete deck. Right. When the concrete deteriorated, then also create the cracking on the deck. Did that cause kind of issue because the life is no protection for the waterproofing membrane if they are combined together as one element, right?
Okay, if you have cracks in your overlay, which happens very often with all overlay materials, and it comes from letting the concrete dry out before it has any strength. And so if you have cracks, What VDOT has typically done is use the gravity field polymer crack sealing material and brush that into the cracks to keep the chlorides out. You do need to do something. And if you don't, I've got a picture of a core from Maryland where they filled the crack with high molecular weight methacrylate, and it's completely filled. So it is possible to fill these cracks with the gravity field polymer, and if you do that, you shouldn't need anything else. And one of the overlays down in 1994 in the Emporia was badly cracked, and we wanted it to be replaced. It was a silica fume overlay, but it was badly cracked, and we said, you need to replace it. And the project engineer said, we're not replacing overlays. We got to get this project done. So we treated it with high molecular weight methacrylate, and we must have done a good job because that badly cracked overlay is still there performing. So these materials can work. The alternative, which is much more expensive, would be to put a membrane on top of the latex or whatever overlay system you have because of the cracking. So yes, you need to do something about the cracks.
Thank you, Michael. I think if we can do that, you're kind of using the one stone kill two birds at the same time. Thank you.
Yes, sir.
Well, lots of questions. Again, if you have any, you can always go on the Latex Modified Concrete Working Group website. That's lmcwg.com. And there's an area there. There's information on latex, specifications from states, a lot of our articles. And there's Michael's email. I don't think he would mind if you ever asked him something directly. And of course, Pat and I always will answer your questions if you want to come directly to us. And also on social media, like Pat said earlier, we're on LinkedIn and Facebook. Please follow us. We're always putting up really neat articles about these overlays that we're replacing that are 40 years old, putting second generations, or where we're putting overlays on new bridge decks. And even in like Indiana, some of our members are going to be involved with doing a whole bridge in one weekend there this weekend, starting Friday night right downtown. I drove over it yesterday. They're going to shut the bridge down, mill it, hydro it, put the early strength latex, and have that thing open for Monday morning rush hour. Just amazing what they're doing on this weekend work. So